Hello guys, so we're going to be looking today at the greatest common factor. Okay, you should be familiar with that because we have done it before. This is just going to be kind of introducing that a little bit further. On the board, notice that you're doing problem set 34, but there's no geometry in this lesson. Okay, so you do have to do all of the problems, unfortunately. Now, what I want to discuss with you is very quickly. On the last video, I talked to you about prime factorization, what a prime number is. So as a quick reminder, a prime number is any number that can be divided only by 1 and itself, and a number that can be divided by more than 1, like the number 4. It can be divided by 2 and 4. Obviously that is not prime, and that term is escaping my mind for the moment. Composite, there we go. It's called a composite number if it has more than one factor. So today we're going to be looking at the difference between a prime number and a common factor. Okay, so a couple of things. When I talk about common factors, like let's say if I had the number 4 and the number 6, common factors are factors that go into both numbers. So I would do that by saying 1 times 4, and then I would say 2 times 2, okay? And then I would do 1 times 6, and I would do 2 times 3. Those are factors of 6, those are factors of 4. The common factors are the ones that they have that are the same. Common means the same. So they have a 1 in common, they have a 2 in common, and that is it. So the common factors, CF, would be 1 and 2. But the greatest common factor is the largest factor that they have in common. So in this case it would be the 2. So the GCF would be 2. Now normally that would be very easy to do and no problem. We just write the factors and then find the common factor. But the problem is that we know that there's very large numbers, and if you do this process it's going to take you quite some time to determine which is the common factor. So we want to use the tool that we did on the last lesson, which is prime factorization, in order to find the common factor. Okay? So as I do that, I want to remind you that any rule that applies to numbers in algebra also applies to variables. So if I had a number like, let's say, well, let me start with this. Let's say I had 2 squared. I know that that means 2 times 2. Well, in the same way, x squared means x times x. Because the base is 2, and I'm multiplying it times itself twice. The base is x, and I'm multiplying itself twice. When I write it 2 times 2, I'm prime factoring 2. The same thing here. When I'm writing x times x, I'm prime factoring the x. So you can prime factor variables by simply expanding them or stretching them. Okay? Let's look at example 1. It says, find the greatest common factor of 8z to the 4th m squared p minus 12z to the 3rd m to the 4th p squared. Okay, so I'm going to find the greatest common factor of that. Now, the best way to do it is, there's going to be different methods, so you're going to have to kind of toy around with what works for you. But I would begin by saying my coefficients first. Okay, my coefficients are 8 and 12. I want to find the greatest common factor of my coefficient. Sometimes it's going to be very obvious, like with 8 and 12, I know the factors of 8 are 2 and 4, and I know if I prime factor 8, it's going to be 2, 2, and 2. And I know that if I prime factor 12, it's going to be 2 and 3. So that's going to be 2 times 2 times 2 is 8. 2 times 2 times 3. Let me turn this so you can see it. No, you can't see that. Okay, there we go. I'm going to factor this. 2 times 2 is 3. Okay, and then 2 times 2 times 2. So that's prime factored. I can use my prime factors to determine what my greatest common factor is. And remember, the way that you do that is you say, okay, which factors do they have in common? Take those factors and multiply them together. So the greatest common factor is the product of the common factors. So it is the product of common factors. Okay? The product of common factors. You should have this definition, but if you do not, it's really important that you write it down. It is the product of common factors. Okay, so what do they have in common? They have a 2 in common. Remember, cross it off. They have another 2, cross it off, and that is it. The third 2 is not in common, and the 3 is not in common. So that means the GCF is going to equal 4 for the coefficient. So that's the first thing, is find the greatest common factor of the coefficient. Okay. The next thing is, now remember that factors are numbers that make up a number. Factors are numbers that also make up a variable. So if I were to take z to the 4th and z to the 3rd, and I were to write it this way, z times z times z times z, z to the 3rd would be z times z times z. This is 3 and this is 4. I would see that they have 3 of the z's in common. So that means that the common factor is 4z to the 3rd. Okay? It can't be 4 because the z to the 3rd doesn't have an extra z. Okay, so 4z to the 3rd. Now, if I were to do that with each letter, m squared and m to the 4th, I'm going to see that they have 2 m's in common. You could do it the same way. You could do m to the 4th equals m times m times m times m. And then you could say m squared is m times m. And I could see that they have 2 m's in common. So it would be m squared. If I do that with the p's, I'm going to see that they have p squared, and p equals p times p equals p. They have 1 p in common. So p. So the answer would be 4z to the 3rd, m squared, p. Now, this work over here on the right is not necessary if you understand one concept. Compare the z's and figure out which exponent is the smallest. Because remember, in order for it to be the greatest common factor, they have to be in both variables, okay? So they have to be in both lists of z's. This one only has 3, this one has 4. So the most they share is the smaller of the 2 exponents. So the answer would be z to the 3rd. If I look at the m's, it's the same thing. This m has 4, this one has 2. But the most they share is the smaller of the 2, so it's 2. And the same thing with the p's. This has 2, this has 1, but they only share 1. And notice I didn't put a 1 there because it wouldn't be simplified. All that to say, you don't have to do this unless you need it and it's helpful. You can simply say z4, z3, 3 is smaller, so my answer is 3. M squared, m4, 2 is smaller, my answer is 2. P to the 1st, p squared, 1 is smaller, so my answer is 1. This is your greatest common factor. I'm going to pause the video and I'm going to do a couple more examples for you, and hopefully it'll click for you.